Okay, let's talk a bit about relations and functions. A relation. Basically, if you've got a set of ordered pairs, so your coordinates, and they are related in some way. So, y equals x squared. Y equals 1 on x. Y equals x cubed. X squared plus y squared equals r squared. If I can write an equation down that links the y and the x, it's a relation. There is a relationship. So there we go. X squared plus y squared is 25. Now, a function is a very special type of relation. Okay? So you can pick any x value you like, but there'll be a maximum of one y value at that x value. Now, it doesn't have to have a y value, but there is a maximum of 1. If it has two possibilities, no good. So looking at our pictures on the wall there, that circle would not be a function. Because if I pick a point inside the circle, let's say I'll just pick x equals 0, there are two possible y values. I could have one at the top, one down the bottom. No good. To be a function has a maximum of 1. So the parabola certainly is y equals x squared. Does not matter which x value I pick, there'll be a maximum of one associated y value. Now, the straight line test is how we can visually tell. So if you imagine getting a ruler and sliding it vertically across your picture, and if it hits that shape more than once, that's not a function. So parabola, imagine sliding your ruler across. Yep, no worries. Hyperbola, slide it across. Oh, hang on. X equals 0, it misses it altogether. That's okay. We said it could miss. It's just not allowed to cut it twice. So hyperbola is okay. Cubic, yep, that's okay. Circle starts out okay. Oh, then we get inside the circle, hits it twice. No good. So visually, that's how you can see if something is a relation or a function. So here we go. Y equals 1 on x. Doesn't matter where I put it. Bang, I could draw a line in. Hits it once. Yes, function. There's a sideways parabola. No good. I drew a vertical line in there, hits it twice. No, not a function. That's just a relation. What it actually is made up of two functions. If I was to make y the subject, I'd end up with y equals plus or minus the square root of x. The top half of the parabola would be the function y equals the square root of x. The bottom half of the parabola would be y equals minus the square root of x. Okay, now, domain and range tells us about the x values and the y values of functions and relations. Domain are the x values. So if you imagine the function or relation as some sort of a machine, and we input and we get output. Everything we input is in the domain. So all the possible things we can substitute in for x and get an answer. That's the domain. To find it, if you're just looking at the equation, look for things x can't be. It's usually easier to find exclusions than inclusions. So here's x equals y squared. Now, if I've got the picture, the domain's real easy because I can see where it exists. So I just imagine walking along the x-axis and go, oh, is there a curve there? Curve down there? No. So this isn't in the domain. Oh, I wonder when I'm getting in the domain. Oh, we hit 0. Whoa, here's the curve. Okay, I'm in the domain now. Yeah, there's some above me, some above. Fantastic. So the domain for that one would be x is greater than or equal to 0. Right? Sometimes you get these split functions, step functions, those sort of ideas. So in this case, the domain would be x is less than or equal to, because it's coloured in. And also x is greater than 2, but not including 2, because that one's not coloured in. Okay. But if I don't have the picture, as I say, got the picture, makes life easy. If you don't have the picture, fractions. What do we know about fractions? The bottom of a fraction can't equal 0. So that's going to cause problems with substitution. So y equals 1 on x. Okay, I do know what that picture looks like. Let's pretend I don't. Bottom of the fraction can't equal 0. So I know x can't equal 0. That's not the domain. You don't write that down. The domain is when you tell me what is included. So whilst I've looked for the things that are excluded, to write the domain down, I have to write what's included. So the domain, I would say, all real x except x equals 0. I can't have x equals 0. So this particular one, oh, hang on, bottom of the fraction can't equal 0. So let me solve that. X squared minus 1 can't equal 0. X can't equal plus or minus 1. Can't substitute that in and get an answer. So the domain for this one, all real x except x can't equal plus or minus 1. Now, if the domain is every number, don't write down all reals. Write down all real x. Okay? Because when they're looking at a solution, they need to understand that you understand it's the x values. So if you just write all reals, well, they don't know whether you mean the x values or the y values, so they don't know whether you understand the question or not. So all real x if everything is included. Oh, two fractions. Okay, rules are still the same. X minus 1 can't equal 0. But the other fraction, 7 minus x, can't equal 0. So we got every number we like, all real x, except x can't equal 1 or 7. X can't equal 1 or 7. The language in this is really interesting because some people say, well, shouldn't I write, say in this first one, x can't equal 0? And I guess it all depends in your punctuation, doesn't it? Because I could say, hey, it's all real x, except x can't equal 0. And then I'd use a not equal to sign. Or like I've said here, I haven't used a comma. I've just gone, hey, all real x except x equals 0. Does it matter? I don't think it really matters. As long as it's very clear you're saying which one is the exclusion, I think you're okay. Root signs. Okay. Can't find the square root of a negative number. So if I had y equals the square root of 4 minus x squared, and again, I'll pretend I don't know what that is. Do we know what that is? Close. It's a circle. It's the top half of the circle. But you were on the right track. It's the top half, because if I was to make y the subject of the circle, I'd go y squared equals radius squared minus x squared. So y would be plus or minus. Same idea that I talked about just before. But again, pretend I don't know that. Don't know what it is. Don't know what it is. So I'd say, well, okay, what I do know is 4 minus x squared has to be greater than or equal to 0. So x squared has to be less than or equal to 4. And in this case, it does give me the actual domain, not the exclusion. X has to be in between minus 2 and 2. If I got two of them, well, both have to be true. So I know x is greater than or equal to minus 3. I also know x is less than or equal to 5. Both must be true. So I want all the numbers that are bigger than negative 3, but also less than 5. So my domain would be x is in between negative 3 and 5, and including those points. 1 over. Let's combine the two ideas. I've got a square root sign and I've got a fraction. The square root sign says, what's inside the square root sign? Greater than or equal to 0. But the bottom of the fraction says can't equal 0. Combine the two ideas together and we just have x plus 2 is greater than 0 rather than greater than or equal to. And so there's my domain. X is greater than negative 2. All right, let's have a look at range. So domain, everything we can put into our machine. Range is once we put all those machines, once we put all those numbers in, what's it spit out? What's the answers? So the output. Okay, there's our picture again. If we got the picture, this time I've got to get an abseiling rope and abseil down the y-axis. And I'm looking, oh yeah, there he is, over there. Yeah, I can see it. Whee! Doesn't matter how far down I go, that curve's going to be there. So in this case, the range is all real y. Again, I'm specifying it's the y values I'm talking about. And our split function, we're going down, going, oh yeah, I can see it, I can see it. We get to 3. Whoa, where'd it go? Hey, it's gone missing. It's not there anymore. It's not in the range. Oh, well, I'll keep going down. Maybe something will happen. Where? Behind me. Oh, look, there it is. So there we get to 1. And so the range for this one, y is less than or equal to 1. Y is greater than 3. What do we look for? Okay. maximum, minimum values. We know even powers and absolute values are always going to be positive. So if I see, here's a very basic one. There's our parabola. Again, pretend, don't know what it is. Y equals x squared. But what I know is the x squared will always be greater than or equal to 0. Therefore, the output of this y will always be greater than or equal to 0. So range, y is greater than or equal to 0. So logically then, x squared plus 3, well, I know the x squared is always going to be greater than or equal to 0. So therefore, my y values will always be greater than or equal to 0 plus 3. So y will always be greater than or equal to 3. 5 minus x squared. Well, if it's minus, then it's going to be less than or equal to. So it's going to be less than or equal to 5 minus 0. The biggest that could ever be is 5, because I'm never adding a number to it. I suppose that's another way of thinking about it. I'm never going to add a number to 5. I'm always taking something away. So it's going to be less than or equal to 5. Absolute value, again, absolute value has to be greater than or equal to 0. So y is greater than or equal to 0. Absolute value minus 5, same idea. Oh, well, I know the absolute value is greater than or equal to 5, so the whole thing's greater than or equal to negative 5. The picture. If you know the picture, that's the quickest way of finding your domain and range. What about if there's restrictions on the domain? When the domain's all real x, very easy to find the range. Sometimes there's restrictions, like our semicircle we just talked about. We said x's are always going in between minus 2 and 2. And so that can cause problems because, well, if I'm only subbing in numbers between these values, then I'm only going to get certain numbers out. General idea, what I do is I'll look at the endpoints of the domain, see what's happening there, and I'll look at the middle as well. Because it's amazing how much symmetry often happens in these things. So there it is. That was the semicircle we were talking about. There's the domain. I'll sub in x equals 2. I get y equals 0. I'll sub in the midpoint, x equals 0. We get y equals 2. I don't think I bothered with negative 2 because I was squaring it. So obviously I'm going to get the same answer as 0. That range then, I'm pretty confident it'll be between 0 and 2. And if you're unsure, if you're uncomfortable with that answer, just sub a few more values in. Let's see if it confirms what we were saying. Fractions. When you have a constant on the top of a fraction, that fraction can never equal 0. You cannot divide a number by something and get nothing. Can't do it. Impossible. So again, back to our, don't know what it is, hyperbola. Y can't equal 0 because that fraction can never equal 0. So therefore my range is all real y except y equals 0. 5 plus 1 on x. Well, that fraction can never equal 0. So therefore I can never get 5 plus 0. All real y except y equals 5. X plus 7 on x plus 4. A little bit trickier this one because there's not a constant on the top of the fraction. But if I rewrite it as 1 plus 3 on x plus 4, now it becomes a little bit clearer. The fraction has a constant on top. So the fraction can't equal 0. So I can never get 1 plus 0. Now, if you're unsure what that is, you could go back to the idea of polynomial division. Remember that? X plus 4 into x plus 7. How many x's in x? 1. Okay. And we end up with a remainder of 3. So therefore it's 1 with a remainder of 3 over x plus 4. So if you're unsure, you could always do that. So y cannot equal 1 plus 0. All real y except 1. I suppose another way of looking at it is I'm going to get a number, add 7 to it, and then on the bottom I'm going to get the same number, add 4 to it. Well, I'm never going to get the same number on top and bottom. So I can never get 1. Okay, some function notation. You see this sort of thing. F with an x inside. It doesn't have to be f, it could be a g, it could be an a, it could be any letter we'd like. F is the most common one, I suppose, because f for function. And so instead of saying y, but that's the only difference. Inside the parentheses, it's telling you, hey, this is the number to substitute in. So if I said function 5, I'd substitute 5 in for x, and that's 79. Doesn't have to be a number, of course. Function a, 3a squared plus 4. Wherever there's an x, replace it with an a. Function x plus h minus function x. Okay, so the first one, wherever there's an x, replace with an x plus h, minus, function x itself, 3x squared plus 4. Expanding out, tidying up, there's our answer, 6xh plus 3h squared. All right, that was a lot of chat. Let's have a go at 2f.